Hello everybody and welcome back to Squirrelyville. Okay, so I want to show you something real quick because it's kind of what I'm doing right now, and I figured might as well show you this. Okay, and this is something to show, you know, people talk smack about expensive cables, and I get it, okay, because some of them you're not getting your money's worth, and it's just it's a fake out. I'm not talking about sound here. I'm talking about just materials, cost, labor, all that kind of stuff. Like, why does it cost more? Okay. Normally you can just shove a little wire into a little plug socket thing like that with a screwdriver, strip a wire, shove it in there, crank it down, you're done. Okay, this is the length and the painstaking process that I go to put into power cords that I make. This is, I don't know if we can focus on that. Okay, there you see. Okay, so it's a hand-cut piece of carbon. You can see that carbon fiber. It's a hand-cut piece. I use the internals of one of these FI50s and use the internal so I can get the NCF in the plastic. So that plastic has minerals in it. It's not just regular plastic. It's a polymer that's loaded with like two or three different minerals that do whatever they do. I'm not going to get into that now. Okay, and then I add my own epoxy. You can sort of see that green stuff in there. That's a compound. I use like 4 different minerals, 5 different minerals that have different properties. Okay, and these are the return, the ground, the neutral, and return. Those are, I don't know if you can see that or not. It's not wire. It's pure solid 5/9 silver. You can't really tell. These are 10 gauge squares. The reason they're squares is because they have better contact surface area with something like a foil than, and these are the, you can see the profile. These are flat and low and wide. So there's more surface contact area with a foil than a round wire, which has a curve to it. So you're only going to have a thin line of contact area with something like a foil. Okay, so this is backfill. The minerals that are in here all do something in the presence of electromagnetism. Some of them, like here's quartz crystals right here. These things vibrate and they elongate and they move when you're in electromagnet in the field. And that means it takes a certain frequency to make these vibrate. Okay, and that frequency comes off the line. Okay, so in other words, energy is neither created nor destroyed. It just moves around, right? So the energy it took to vibrate these puppies has to come from somewhere, right? It comes from the electric, your AC power. And it comes at a certain frequency. This size is for a certain frequency. That means I'm pulling a certain frequency. I'm pulling the energy off the AC line. I'm pulling a certain frequency away from the AC line to go into these crystals to make them vibrate. Okay, so that should make sense to you. Okay, and then so I fill it up here, and this is the mix with the, these are certain types of ones that act different. They have to do with magnetism and so forth. This one, so because it's a loose one, one that needs to vibrate, if I seal it up in the epoxy, it's not going to be able to vibrate. It'll be all tight unless I have like a rubber epoxy or like a silicone, it might work. But so this will come in. I'm going to try and do this one-handed. You get the idea, and I'll clean this up afterwards, but okay, so what's going to happen is I'll take this, okay, tap this out. I'll fill it up a little bit more so that there's a nice even level of that, and then I'll come back and I'll put more potting on top of this. So now what I've got is I've got a sealed chamber with loose quartz crystals in there so that they're able to vibrate and do their thing without being contained within a polymer or a potting compound. Okay, so this will get, and it looks maybe like this when it'll be done, okay? And so that'll be sealed up, okay, and then this goes into the foils, okay, so let me see, here's a wire, this is 10 gauge, this is a huge wire, okay, so this would be like, normally someone says, oh, 10 gauge, power cord, and you're going, oh, wow, 10 gauge power cord, that's pretty big and heavy. Well, all it is it's this thing right here. It's, you can buy it off the shelf, it's inexpensive, this is silver-plated copper, so it's a lot more expensive than regular copper, but look at what we're talking about here, and we're comparing it to. This is 99.9997 pure silver, okay, and it is thick enough that, like, and there's 2 of them. I've got them doubled up. I mean, I can't like, if I was to, I don't know how to tell you the thickness, but this is a thick piece of silver, okay, and it's the whole freaking length of the cable, and it's 2.5 inches wide of pure freaking investment grade silver. When you buy silver and it's on the market and you're buying bullion, that's how I buy it. And then I have it rolled down and made into this size, which is the certain specification. Okay, so this is pure high purity silver in 2.5 inch, as long as the cable is. And there's 2, okay, on one leg. There's 2 on the other leg, okay. And this, I don't know. Look at any damn cable in the market. There will be none. Just show me if you think there is that contain more precious metal than my cables do. Okay. I'm just trying to show you, because people think that things are hidden inside these jackets, like we hide shitty copper or whatever. You know, you can use copper for a ground. It doesn't matter. I use a copper and a silver for the ground. The legs are pure silver in this build that I'm doing right now. But this shows you the amount of pure silver in a high purity. Do yourself a favor. Try and locate some of this stuff. You can't. You know, Mundorf has something like it, you know, but not nearly the size, because it's an opulent amount. It's way too much. It's like you'd never, it doesn't make sense for a big company to make anything this big, because it costs way too much money. Okay, I do it for the enthusiasts of us that are OCD HiFi guys that really want the best there is. Well, we use big old chunks of high purity silver foil, okay, silver whatever. Sometimes people use wires. My shtick is foils. I've done a lot of testing with the foils. They work very well. So this is bigger than this is actually bigger than a 10 gauge equivalent. But you get an idea. I wanted to show you. I figured I might as well show them inside the cables while I'm doing this build, so they get an idea of what they're paying for. Because unless somebody shows you what I'm showing you right now, you're left up to your imagination, and you can't even imagine this. You know, I couldn't even imagine this when I started. You know, it took me, let's see, it's 15 years in the business of designing my own cables, and you know, and to come up with something like this. This is a refined design. So so I just wanted to show you that. Also, here's another little kind of an important part of the connectors. Okay, so normally in a connector like that, you would have, okay, so look in here, you see that and on the other side, those are for the screw threads. Okay, because what you do, well, knock that over. I'll have to mess to clean up over here. Okay, so what you do is you in these holes you put these long screws. You put that down and you screw these long screws down into there. But you know what? Those screws are made from brass, or they're made from sometimes steel, or and you know what? Those if you put a steel screw or not a brass, but if you put a steel screw in the presence of electromagnetism around AC, it magnetizes. Okay, so it turns into a temporary magnet, and then it takes a while for it to go away. So it's magnified. It's magnetized. So that can cause eddy currents. So you've got current, okay, coming down through here, right past that screw. That screw becomes magnetized. It's going to attract some of the electrons towards it because of the magnetism that's here. So it's going to, let's just say, it's going to interact with it on some level. We don't even need to go into how or what or if it matters, but it's going to interact with it. Okay, I remove the chance of that. I remove all. If you see, because this it has the potting and everything, I can remove all the screws. So there is no screws on my connectors, okay? Inside these things, let's see if I can find one over here. Inside these things, if you go underneath, like these clear covers, let's see. Okay, so here's an example. Okay, so if you take, for instance, a piece like this, okay, this is an IEC, this is a Furatech, and you remove this little clear thing, this puppy right here. Okay, you take that off. See all the metal that's in there? There's a screw here. There's a clamp there. Okay, you can bet that these are not copper. Okay, because these are crucial in holding tons of pressure. So you can't do that with copper. It's way too soft. You need to do that with a ferrous metal. So that means these are magnetized for sure. That little clamp piece, those are all magnetic. They become magnetic when you get them in the presence of the AC power. That can cause eddy currents, everything like I just said. It'll interact, it becomes magnetized, so it takes something away from the AC power to magnetize. It has to pull energy from somewhere to put energy in itself. So but I take these apart and I remove the whole screw and the clamp and everything, and then directly to the Okay, and it's time for a little lunch break. I don't know anybody is from Costa Rica, but this is gallo pinto, which is a traditional staple eaten in Costa Rica, mainly for breakfast. But you can have it for lunch too, any time of the day really, with some cafe. Good stuff. So have a little of that. It's like summer here, man. What? It's a January, February. It's like February, what, I don't know, 3rd, something like that. Man, it must be 85 degrees. It's hot out here. Yeah. All right. Back to work. Okay, and so here is how, that's the final. You know, this is all, you know, filled. And then, you know, the foils go up, and these are the lead outs, and bam. Pretty kick-ass contraption there. So, anyways, that's just to give you a little vision or a little sight into what materials are inside, at least the Virastar cables. So anyways, that's that, and hope you enjoyed it. See you.